Hello everyone, I think I am live now. Today we would be discussing Leetcode Biweekly contest 125. Before we get started, can anyone confirm if audio and everything is fine? I am not at my usual place right now, so there may be some hiccups which we can sort out before we get started. Or can anyone load the Leetcode website right now, or is it just my internet? It says you are given 0 index array nums and an integer k. In operation, you can remove one occurrence of the smallest element of the nums. Return the minimum number of operations needed so that all the elements of array are greater than or equal to k. So let's just look at the samples ones and see what is the problem statement asking. Problem statement says if we have an array in the first sample it says 2, 11, 10, 1 and 3 is given array and k equal to 10 is given to us. And it says in each operation we can remove the smallest element from the given array. So for example, if we do the first operation, 1 will be deleted from the array, and if we do one operation again, 2 would be deleted from the given array. And then if we try to after the first operation, the remaining array would be this one would be deleted from the array. So the updated array would be 10, 11, 3. And if we do one more operation again, this time the smallest remaining number is 2 here. So it will get deleted from the array and the updated array would be 11, 10 and 3. And we have been also given that k is equal to 6. And we have to keep doing the operation as long as there is at least one element which is less than 10. So so the updated array 10, 11, 10 and 3 will also 10, 11, 11, 10 and 3 will also has an element which is less than 10. So we should do one operation once more and delete this time the smallest element from the array. So now all the elements are greater than equal to 10, and if we count the number of operations, we have done 3 operations. In the first operation we have deleted 1. In the second operations we have deleted 2. And in the third operation we have deleted 3. Okay, probably there is some lag. Okay, just let me know if there is a larger lag when I am sharing my screen, whiteboard. Let me just check something. So what we have been given is in one operation we can remove the smallest element from the array. And in, for example, in the first sample we have elements 2, 11, 10, 1 and 3. So after the first operation the smallest element is 1, it will be removed. The remaining array would be 2, 11, 10 and 3. And there are elements which are less than 10 in this array. So we will have to do an operation again. This time the smallest element is 2. We will delete it again. and then the remaining elements are 11, 10, and 3. This array still has one element which is less than 10, so we will have to do an operation again. So this time we will delete the smallest element, which is 3. The remaining array is 11 and 10, and all the elements are greater than 10. So now, like, if we count the number of operations, in the first operation we deleted 1, in the second operation we deleted 2, in the third operations we have deleted 3. So the total number of operations we have performed is 3. And if we try to generalize it, we have to delete all the elements. Since we are only deleting, we have to delete all the elements which are less than equal to 10, which are less than 10. And because in each operation we are deleting the smallest element, what we can do is we can count the number of elements which are less than 10 and print that as an answer. So if you look at our original array as well, there are 3 elements which are less than 10, which is 2, 1, and 3. That's why the answer was 3 here. And like, this is essentially the idea for this problem. I assign answer or count equal to 0 for x in nums. If x is less than k, I add +1 to the answer, and at last I return answer as a given array. And like, since n is less than equal to 50, you can do it in order n square as well. And like, this was essentially the idea for this problem. Any questions on this one? I will move on to the second problem as well, which had similar approach. And if there are any questions on this problem, I can take them up after I am done with the second problem. Second problem says you are given a 0 index array nums and an integer k. In one operation, you take the two smallest element x and y in the nums and remove x and y from the nums and add minimum of 2 times x plus maximum of x comma y anywhere in the array. Note that you can only apply the described operation if num contains at least 2 elements. Return the minimum number of operations needed so that all the elements of array are greater than or equal to k. And like, let's take our original example again, like same sample for this problem as well. Like, the original sample was 2, 11, 10, 1, and 3. And we need all the elements greater than or equal to 10. Notice that all the operation is there, we don't really have a choice. Like, at any point of time, we know that we have to pick the smallest 2 elements and do the given operation with them. So the first time when we are trying to, like, right now this array does not have elements which are less than 10. So we should perform some operations on it. For the first operation, we will take 1 and 2. And we will add 2 times minimum of 1 plus maximum of 1 comma 2 in the given array. No, once. I hope my bandwidth would be better now. So after the first operation, we will add after the first operation, we will add 2 times minimum of 1 comma 2 plus maximum of 1 comma 2, and it is 4. So like, we will remove 1 and 2 and we can add 4 anywhere. So after the first operation, our elements would be 11, 10, 3, and 4. And because this array also contains an element which are less than 10, we should perform an operation again. This time we will choose 3 and 4 2 times minimum of 3 and 4 plus maximum of 3 comma 4. This is 2 into 3 plus 4, which is 10. So these two elements would be deleted and 10 would be added. 11, 10 and 10 are there. And you can notice that all the elements are greater than or equal to 10 over here. So the number of operations that were required was 2 over here. And like this was also the idea for this problem. The one thing to notice over here is like we don't really care about the position of elements in this array. What we need is like which is the smallest element and is the value of smallest element less than or equal to given array. So we can use a priority queue to find the minimum element in the given array and like the second minimum as well, and then we can do the operations. So like if I jump onto my code for this one, like the default priority queue in C++ is max priority queue. So to get the minimum element, what I did was I multiplied all the elements by -1 over here. So now so for example, if -1, -3, -2, -11 and -10 are there, then the maximum value among these is -1. And if you look at its absolute value, that 1 is the minimum value over here. And now as long as this array contains at least 2 elements and the element at the top, like the smallest element is less than k, I pop the smallest element from the queue. And I also pop the second smallest element from the queue. And then I push like the new element, which we would say. Like there are other ways to create a min queue, minimum priority queue as well. Like here you can pass greater LLI function, I believe. That will also work. So this was the idea for the second problem. Any questions on the first two problem before I move to third problem then? Okay, third problem. Third problem says you are given an unrooted weighted tree with n vertices representing the servers from number 0 to n-1. An array edges where edge I is ai to bi with weight wi represent a bidirectional edge between vertices ai and bi of weight wi. You are also given an integer signal speed. Two servers A and B are connectable through a server C if A is less than B and A is not equal to C and B is not equal to C. The distance from C to A is divisible by signal speed. The distance from C to B is divisible by signal speed. The path from C to B and the path from C to A do not share any edges. Return an array count of length n where count I is the number of server pairs that are connectable through server I. Like for example, this is the given sample. Like let me draw it once. And okay, problem C. Like let me draw the given graph as well, which is given in the input. Signal speed for this is 1. To be honest, it doesn't really make sense if signal speed is 1. Like all the numbers are divisible by 2. So let's just solve it for the case when signal speed is 2. Or probably let me just take the second sample in that case. That is better. Zero, 3, 1, 4, 2, 6, 5. The edge weights are 3, 3, 1, 6, 2, 7. So this is the given tree. Like the first approach I have is order n square. For that, the idea is like we root the tree at for each. If we want to find count I, we root tree at vertex I. And so, for example, like if we have this vertex I, and like there are some subtrees over here. Like this is the root, which is vertex I when we are counting for the node. These are the children of I. Then, like for example, like we don't really care about A less than B. What we need is like because the vertices are different, one of the vertex would be less than the other definitely. And we also need A not equal to C, B not equal to C. And like from path C to B and from path C, like because path C to B and C to A do not share any edges, then the only way this can happen is like the only way like the paths cannot share any edge over here is like they are from different childrens of I. Like if you pick any node from this tree and any node from this tree, the path would be this and this half would be this. While let's say if you pick two paths from here, then like they would only meet here and they will not reach C. And if you try to find A to C and B to C, then this path would be shared over here. So like the idea is root tree at I are from are in subtree of different child of I, then C to A and C to B will not share edges. So like this is one part. And now we also need that the path should be length should be divisible by the given array, right? So like what we can do is like for each subtree we can count like the number of paths that are divisible by given length. And the path, if I is the root, then path I to B is height of V when tree is rooted at it. Like path I to B is would be the height of node. So like if we can find the height of all the nodes and for each subtree we can maintain like how many children are there which are length divisible by that, then we are good over here. And like that was the main idea for this problem. Like notice this was n square works because n is 1000 over here. So what I am doing is I am routing the tree at all the nodes. Like first I have created an adjacency list where there are weights. And then I'm running a DFS. I have written a DFS function, like I can separate it out to make it easy. And then I am running the DFS from the each child of the root. and the initial height as that node over here. And I have a count variable which denotes like how many children have the height divisible by the given example. Okay, I will also run a dry sample with one example. Then when I am running DFS, if height is divisible by signal speed, increase the count. Otherwise, iterate on all the paths, like not going back to the parents, and run the DFS algorithm again, where the height plus the current edge length would be the new height for all the children. And when you are done, your total count is like total number of nodes which have height divisible by signal length, which have been processed so far. And count is the new nodes which we have discovered. So we multiply both of them, like this would be the new number of pairs which would have. And then we also increase our count, and at last we are returning the answer which is the given vector. And like I should dry run on the sample ones. Okay. Okay, in the given sample, like let me dry run it on n equal to 6 there. 6 is the root. 5, 3. 0 is at distance 1. 1 is at distance 6. 2 is at distance 4. 6, 0. 3 is at distance. 6 to 0 distance is 3. 3 to 4 is at distance 2. And 3 to 2 is at 7. So when we want to find the number of nodes at distance 6, we should root the tree at 6 and find all the heights. So like height of 5 over here is 5 is at distance 3, height is 3 for 5. And now when we are running DFS on the second part, like for 0, like the distance from the 6 and the height over here is 3. And now when you move to 3, like the height of updated 3 is height of parent, which is 3 plus the edge distance. So the height of 3 is 4. Now when we move to the other node using a DFS, like the height of 4 is like height of 3 plus this edge length, which is 6. And similarly, when we are at 2, like the height of 2 is like the height of 3, which is 4 plus the edge length, which is 11. So the values in blue is the height of each nodes. And our signal length is 3. Signal strength is 3. So in this subtree, like in this subtree of like the child of 3, like there is only one node which is divisible by 3. And in this subtree, like 3 is divisible by 3, 6 is divisible by 3, and no other number is divisible by 3. So in this subtree, 2 nodes are divisible by 3 here. And because we want to count all the pairs which are from different subtrees, in this case, like 3 from here and 4 from here would have is a valid pair. This is 5, right? Okay. 5 comma 4 is a valid pair. And 5 comma 0 is also a valid pair. And hence 2. And like this is the idea. Any questions on this one? Like if there are any more questions, like I can take them up. And like questions apart from like the contest discussion, I will take them as the end. And I will, like if there are some questions like any advice or etc., I will take after I'm done with the fourth problem. So any questions on this one? Like what I did was a shortcut. What you can also do is, like for example, you can create an array. for each of the subtree in a map or something. Like for example, in this case, you can create an array 1, 2. Like 1 is like the number of nodes from the first subtree, that subtree of child you process. 2 is the number of nodes from the first subtree you process. And total numbers which are divisible over here is 3. So what you can do is 3 square minus if both of them were picked from here, 1 square minus 2 square if both of the nodes were picked from here. And like this would be 9 minus 1, 8 minus 4, which is 4. And all the pairs would be counted double over here. So you can divide it by 2 as well. So like the other way is like if total is the total number of nodes at given distance and count A1, count A2, count A3, etc., where A1, A2, A3 are children of I, children of root I. Or like the other way you can do is like if S is the total count, SC2 is the total number of nodes you have, and A1 C2 is the total number of nodes you have from this one, A2 C2 minus A3 C2. Like these denotes like this is the case when both of the pairs were picked from the first child. This denotes the case when both of the pairs were picked from the second child. This denotes both of the pairs were picked from the third child. And this denotes the total number of ways to pick all the nodes. And like this also works. Like I will modify my code to show this one as well. So like pairwise product is like if you want two different, what you can do is like I am subtracting this as the value which should be so like Subhamas like 4 2 2 1 is the one, right? So what you can do is you can count the sum. 4 plus 2 plus 2 plus 1 is 9. So 9 C2, which is the number of pairs from 9, is 9 into 8 by 2, total number of pairs, minus when both of the pairs are from the first node, which is 4 into 3 by 2, minus both of the pairs are from the second node, which is 2 into 1 by 2, minus if both of the pairs are from the third child, which is 2 into 1 by 2, and the last one has only 1, so there would be 0. That would also work. So like this was the idea for the third problem. And like one bonus for this problem, like our current time complexity is order n square, right? It is also possible to solve this problem for n log square n time complexity. And the idea for that would be heavy light decomposition. No, wait, not heavy light, centroid decomposition would be the one. So like the ones who are interested can try out solving it in order n log n as well. And if there are doubts like how to solve it or if you are stuck, like then I can share it on Discord server as well. For this stream, I will skip this bonus part here. Okay, and like so there are some questions in the chat. In the second question, why did you multiply minus sign? Can you explain your intuition? Yeah, like the reason for multiplying minus sign was the default element in the priority queue returns the max element. Like if you did not write auto and in the for loop, then Okay, TLE, like that was the same reason I got TLE Arindam Pandel in the last contest. The problem is like this is a vector over here. So when you run this for loop, you will create n minus 1 copies of edges over here of the vector. And although the vector length is 3, it takes quite a long time. So like if I submit now, I expect a TLE. Okay, it worked, but yeah. Like in the last contest, I got TLE because of this simple reason. Okay, like right now I'm discussing the third problem. So like default priority queue, like is lookup for the largest element at the expense of logarithmic insert. Yeah. So that was the reason when I multiplied all the elements by -1, then I got the largest element is the minimum element with the multiplied minus sign over there. And like the other way to deal with it to avoid minus sign is this one. Like you can also define a comparator over there. And now you no longer need. Like this is different from like Python and everything. Like in Python, I believe by default minimum element is returned. So like you can change a max priority queue to min priority queue by using this sentence. Like you can define a custom comparator function and that will take care of. Yes, you are right. Like I want multiply by -1 because I want elements in the increasing order. So like that is the main reason for multiplying. And like the other way to get in increasing order is you can define this long sentence to get min priority queue and do it without a minus sign. So any questions on the first three problem before I move to the last problem for today? Okay. I will wait a minute more if anyone has any questions, or then I will move to the last problem. So for centroid decomposition, you can check use our guide. Okay, third was not clear properly. Okay, I will try to summarize third once more. Like the first thing in the third was like n was up to 1000 only. So what we can do is like we can fix each node I and we can count like how many nodes are at distance s from there. So for example, if we fix a node I, then there would be some neighbors of I like this. And then there would be more nodes on this path. The first thing to notice over here is like if you pick any two nodes which are below the same child, for example this one, then this path and this path will contain this as a common edge. While if you pick two nodes from two different childs of two different neighbors of I, then these do not contain any intersecting edge. And then the idea was to do a DFS algorithm to find distance of each node from I. And like, let's say like this neighbor of I has C1 nodes which are divisible by signal speed. And this child has C2 nodes which are divisible by signal length, start at a distance from I. This has C3, and this has C4 nodes. So like the total number of nodes which are plus C4. So like the total number of pairs that are at distance, like assuming, like if we ignore like common edge part, like if we ignore this part, then like total number of pairs would be T as the first pair and T minus 1 by 2 as the second pair. And now what we can do is we can subtract, like the first case can be like when we picked any two elements, they were from this node. So we should subtract like those number of pairs. So those would be C1 into C1 minus 1 by 2. Like these are the total number of pairs when both of the nodes would be picked from the first neighbor of the R root. C2 and C2 minus 1, like this subtraction is done like for the case when like we have picked both of the pairs from the same neighbor, which is second neighbor of the child. This for the third neighbor and this was for the fourth neighbor. So like if we know like how many nodes are at a distance divisible by signal speed for each of the neighbors of a root, like each of the first neighbors of an I, then we would be able to find all such pairs by using this formula. Like any questions on this one again? And like the way to find this neighbor was using DFS algorithm. Depth first search. And like if probably like it can happen like some people are new, and so like depth first search is a commonly used algorithm. So like you should check out this USAO guide for like how to do using depth first search. Like so now I will move to the third problem. I don't think we can do it in order n for each test case. Order n log n might be possible, but I am not sure about it. But I am sure order n log square n is definitely possible using centered decomposition. So like coming to the third problem. Now I will start the fourth problem. I will start for the last problem. It says find maximum sum of nodes. There exists an undirected tree with n nodes numbered from 0 to n minus 1. You are given 0 index 2D array edges of length n minus 1, where edge I is ui vi indicates that there is an edge between node ui and vi in the tree. You are also given a positive integer k and a 0 index array of non-negative numbers nums of length n, where num I represent the value of node numbered I. Bogdan wants the sum of values of the tree of nodes to be maximum, for which Bogdan can perform following operation any number of times, including 0 on the tree. Choose any edge u and v. connecting nodes u and v and update their value as nums u becomes num u xor k and num v becomes num v xor k. Return the maximum possible sum of values Bogdan can achieve by performing operation any number of times. So like this is the problem statement, and if you look at the sample, in the first sample 0 1 2 is given and k is equal to 3 is given to us, and these are the edges. It says we can achieve a maximum sum of 6 by using a single operation. If we choose the edge 0 to 2 and change nums 0 and nums 2 becomes 1 or 3, which is 2, like 0 and 2, like both of these are 1 and 1, right? So this one becomes 3 and this one also becomes 3, and the total sum becomes 6, and it says like this is the maximum we can have. Similarly, if we look at this sample, in this sample the elements are 2 and 3 and k equal to 7 is given. So it says we can get a maximum sum of 9 if we perform the only operation over here, XOR. And similarly, like all the elements are 7 over here, k equal to 3 is given, and it says to achieve maximum sum we should not perform any operations. So any questions on the problem statement first, like what it is asking us to do? Like before I move on how to solve this one? Okay, the idea is fine. Next, the idea was using DP on tree. DP on tree was the idea. Like first thing you should notice is like what happens when you perform an operation on node 2 times. So for example, let's say we have chosen this head and we have chosen this head. What happens? If this value is A1, A2 and A3, after the first operation, like let's say we first perform operation on this edge. Then the updated value becomes A1 XOR K, A2 XOR K and A3, and like I am not changing anything over here. And now if we perform an operation again on this node, like our updated array becomes and A2 XOR K, A3 XOR K, A1 XOR K, XOR K. And if you look at some of the identities of XOR function, one of them is like if you do XOR of the same operations again, then the value is 0. And like if A XOR B XOR C is there, then you can either find XOR of A and B first and XOR of C, or you can also find the XOR of B and C first and then XOR it. Like these are equal. So like using these two, A1 XOR K becomes A1 XOR K, which is A1 XOR 0, and like which would be A1 itself again. So like original node remains same if even number of edges are performed using it. Yeah, that's the correct observation. So the next idea was Like we have different nodes. Let's say this is a node U. Then DPU0 denotes we have performed some operations in the subtree of U such that the number of operations performed on U is even. That is, remainder over there is 0. In subtree of U such that number of connected to U is even. Basically, this is reminder modulo 2. Similarly, we define DPU1 as we have performed some operations in subtree of U such that number of edges connecting U is odd. And like this is one way to solve this problem. And now if we want to look at the transitions, like x1, x2, x3, x4, U. Then if the number of operations performed with x1 in this subtree is even odd, then we will add a of x1 k to the answer. And if the number of operations performed is even, we will add a of x1 to the answer. Or like not even in the subtree, we can also advance one edge from the parent as well. Like we can, this is not just you, number of in subtree of U and parent edge. U and P. And DP0 would be subtree of U and parent edge U and P. And once we do this, we can start off with initial value as I am denoting a pair AU and AU XOR K. Then we iterate using DFS. And like if DP x1 is with us, then what can happen over here? X1U. Either we have used this edge or we have not used this edge. Like there can be two cases, right? If we do not use this node, then DPx10 contributes to DPU0 and DPx11 contributes to DPU1. And if we use this edge, then the contribution from everything else would be flipped over here. No, wait, one thing, wait, I am doing something now. And I feel like there is one easy way to solve this problem as well. Like let's operate it more. I have realized we don't even need a graph here, but that's a different story. Let's say we have this x1, there are some children. Like overall, whenever we are performing a flip operation, we change two nodes, right? So total nodes change is even. Any questions on this one first? And my claim is if we choose even number of nodes and take XOR, then we will be able to find edges we need. Like any questions on this? Like ignore the earlier part first. There are two claims. Like whenever we perform any operation on the head, like we change two nodes over here. So either we have chosen the two existing nodes which have already been flipped, and if we flip, both of them would revert back. Like u2v, there is an edge, and like the current value is u2 sorry and u1 sorry. Then if we perform an operation on this edge, we will get u1 and uv. And if earlier the number of nodes which XOR k is even, then now also the number of nodes with XOR k is even. Similarly, we can try the other case as well. Like if current value is u2 uv, and if we perform XOR, then we have increased the number of nodes where we have taken XOR k. So that is even as well. And the other case is this is there, and now if we perform XOR over here, like we will get u2 uv XOR k. And now this has been toggled back to original set, but this has been changed. So in this case remains same. In this case, two nodes increases. In this case, two nodes decreases. And zero change. Count. So any questions on this claim? Like if we choose like either 2, 4, 6 or 8 even number of nodes and flip them XOR k, then we will be able to find a path which connects all of these nodes. Like if there are no questions, then the next part would be easy. Like if I have to prove it, like why we would be always be able to find such nodes of edges is because like the tree is connected. And let's say we have flipped x1, x2, x3, x4 over here. Then we can randomly pair any two nodes and perform operations on the path joining them. Like for example, here if we want to change x1 and x4 as a pair, we can perform operation on this edge once, then this once, then this once. And at the end of this operation, like ax1 XOR k would be there and ax4 XOR k would be there. And like because this is connected two times, like the value over here remains same. Any questions on this one? And now if this is the case, then what the DP state we can define is TP usually when the number of flipped nodes by k is even in the subtree of u, and the other would be DP u1 is number of nodes is odd in subtree of u. And we can use the for if we want to find for u1. Then we can count over here like 0 comma 1 0 comma 1 0 comma 1 0 comma 1 is there, and either we flip this node or we do not flip this node, 0 comma 1 would be there. So we can maintain a running sum starting from here. First we start with only u as flipped, so our state would be au comma k. And then we look at first child of u. So either like for 0, what happens is like we take max of 2. Like one node was changed from the subtree of x and one node was changed over here, or nothing was changed over here. This would be the case when even nodes have changed. Similarly, if we want to find the odd nodes have changed, it would be either this node is changed and nothing is changed on this subtree, or like there are odd number of nodes in this subtree and nothing changes over here. And now we can use the result over here to even go for dpx2 and add that to given dp state as well. Like here I am taking all the nodes as input, then I am running a dfs algorithm on it. Like because there are only two states, I am maintaining a pair over here. If even number of nodes have changed so far, so if we do not do anything on u2, even nodes number of nodes have changed. If we perform operations on u2, then odd number of nodes have changed. Then a dfs algorithm on all the children of u. Like let child be the dp value over here for given node. Either we have not changed anything so far, and the child, like so far, like we have even nodes, and like we also take even nodes from the child, or we take odd nodes from the child and odd nodes taken so far. This would give us the case when like we combine this x with the current running sum we maintain. And if we have to have odd number of nodes change, then that would be either currently we have odd number of nodes change and nothing changes over here, or we have changed the odd change no even number of nodes changed so far and odd number of change over here. Like I think this can be written in a better brute force way as well. Like let me write a code which gets TLE first, and then let's see this optimization. Right now it does not make sense. Like child u, the first node denotes nothing has changed. Like we can just keep it 0, that works. Like max of both the cases. Plus odd number of nodes have changed from the child. Like let's just denote vi as well. Let's just remove pair for now. Like now the dp value returns like how many nodes we have changed. The updated value would be n plus n. Like if I have changed I nodes so far and j nodes from the subtree, then this will impact I plus j. And now we should replace node change after adding all the child nodes over here. And now my answer is that even number of nodes should change. Like this will get a TLE, but like that TLE ML is fine, but like are there any questions on this algorithm first? Like I know I may have been a bit vague or I may have missed something over here. And like, but if you understand this algorithm works, then I can say further optimization. I will go through the further optimization that needs to be done. Like this is order n square algorithm where I am maintaining for each child like how many nodes have changed for them, and then I am trying to combine it with for the parent as well. Like any questions on this brute force algorithm first? Like then the next idea was like because we only care about whether node is odd or even, instead of using a vector we can also use a vector of size 2. Like do you want me to explain something again over here once? Like any questions or anything which is not clear so far? Like I know like I went through a different solution first and then a different solution again. Like or if you want me to turn through a walk through a working example of how things are changing over here, then I can do that as well. And like one more way over here is like we don't even need this graph altogether. We can just ignore all the edges as well. Like that was something which I realized much later. Initially, I marked node change as infinity because if nothing is done, you cannot have odd number of change. And now I iterate on all the elements of the given array. Everything is infinity. Either we do not change anything, or we take odd nodes from the original graph and add it over here. And if final result is even, like then, or is either we should have even nodes changed so far, or we should take or even number of nodes so far and change x over here. And because we want odd number of nodes changed, then like this algorithm also works. Like we don't even have to care about graph at all here. Like this short code will also work. And like this was the main part of this problem. I can take some questions on the chat before calling it a day. And like thanks everyone for joining. If there are some questions, I will take them from the chat, and once I am done with them, like I will end the show. Okay, first question is, wait, hold on, just on talking about centroid decomposition lead code contest. No, I was not talking about centroid decomposition. I simply said like the algorithm allows some brute force type of approach, but if you use centroid decomposition, you can get a better result over there. Like for the problem C, order n square is allowed, but if you want n log square n, you can use centroid decomposition. And Aditya's, why do you name yourself yet another YouTuber? Like I simply edited it because I thought like I may mess up some different something while I am starting out. And if someone says, look, he's a vulnerable YouTuber or something like that, then I can say like just I am yet another YouTuber over here. But I do plan to change it to something else. I'm just looking for some other name. Or I will simply change it to RNC403 after some time. Like Arinman says, I would try to attempt myself, then I will see this. Your Arinandam, I hope I am pronouncing your name correctly. And like if you have some questions, like you can also join Discord if the video is not clear or if you want me to explain something there. And but yeah, I know basic DSA, but I want to get into depth and learn CP. How should I proceed? Like one thing which whenever someone is asking me this question, what I suggest them is you can join the Discord server, and there I have a channel like roadmap to read in 2 minutes. Although it's a clickbait, I try to add some starter tips over there. Like that can be one way. So like this is a Discord server, like where I started. Like first thing was you should try to solve ABC, etc. Next one was like if you want to master some topics X, then how you can do is. Third one is divided into 3 parts. I have only posted first part so far. like how do they reach X rating. So if your goal is to reach expert or below, this is what you can do. And then I want to post something for like candidate master until like what I did when I jumped from candidate master to master, and then what I did when my max rating on code forces was a red point over there. Like that, those two would be the next two parts. And like here, like you can either read CSCS booklet and solve their problem set. You can also refer USACO guide. Center decomposition I said was from here. And like there are other sources as well. But yeah, and like the link for this Discord server is in the description. But yeah, I have mostly solved ad hoc problem related to array strings. I haven't studied graph tree or DP. I know binary search. What topics should I cover first? Okay, like generally, like what I have is like what the way I have done problems is like I try to solve contests and try to solve problem. So if you are solving right now and you see a lot of graph problems are appearing, then it's better if you study graph and tree right now, because that can help you in the next contest. But for example, if you see something else over there, then like a dynamic programming or something, there are way too many algorithms in this guide, and like it has a detailed instruction as well. Like for example, they have divided like bronze is the easiest section, then silver, then gold, and then platinum is the way you should go. Then here you can look see like a lot of topics are there. For gold, which is generally candidate master on code forces, like here math related topics are there. Dynamic programming is there. Introduction to DP, knapsack, path on grid, graph. 79 sections are there for the graph. I think this is 79 problems, and like the topics are less over here. Data structures are also there. And if you are bronze, like you have just started out, you can start over here. Like 15 problems are related to time complexity, data structure, simulation, and like a frequency is also given over here. Like how many times a topic appears. Complete search using recursion is rare, but basic complete search is very frequently asked. Sorting, searching, additional ad hoc problems, greedy, etc. is there. So like you can try out this side. And like there are any more questions over here? Like I think someone in the chat, like someone was asking like how do they look at their rank? Then like if you look at the contest page over here, the here are the problems and here is the rank list over here. So like you can check here. Like that's how I know like I was sixth in this contest. And someone was asking, is it go from leaves and greedily check if we can from MSB to leaf? No, that was not the correct idea for problem 4. And like the code was short. Can you share your lead code ID? Like my lead code ID is literally YouTube underscore Aryan. And like I think that was also the reason why a lot of people find out that I had a YouTube channel. Lead code ID is also in the this video description there. YouTube underscore Aryan. It's AryanC403, yeah. So if there are no more questions, then I will call it a day. Thanks everyone for joining. Yeah, like you can find all of my profiles here. So like my YouTube channel, Discord server link, LinkedIn, GitHub, ICPC profile, Code Forces, CodeChef, AdCoder, Leetcode, Twitter, and pretty much these are the places I am active right now. So thanks everyone for joining today, and all the best for future.